of WindSim, we welcome you to the webinar today, and we wish you all a Happy New Year. We will provide a preview of the following upcoming features that will be released in WindSim 6.0, which includes the WindSim Express technology. All of you that have running annual maintenance agreements will automatically be upgraded to version 6.0 this quarter. Version 6.0 is a major software upgrade, and we encourage all of you who have not renewed to do so. The duration of this webinar will be 1 hour, and the participants are all muted to enhance the performance of this webinar. We ask that any questions that you'd like to send, you send into the host, who's called WindSim WebEx, or host on your chat window. So you send those via chat. Anytime during this presentation, you can send those in, and we will address as many of these questions as we can at the end of the webinar. And with that, then, I turn this discussion over to Dr. Catherine Meissner. Thank you.
Thank you, Donna. Welcome, everyone, to our WindSim webinar series. Today, I will present you WindSim Express. My name is Catherine Meissner, and I'm the Software Development Manager in WindSim AS. Short about the outline of the talk today. The content will be that we will first speak a bit about what a perfect CFD software would be, and then we will speak about a bit how the reality looks today, and then we will show you how we close this gap and how the CFD tool WindSim will work in the future. We will present you the WindSim Express and the WindSim 6.0 version. In the end, we will speak a bit about the new developments in the next month, and then we will let you know how you can try everything out. So what would be the perfect CFD software? First of all, it should be usable by everyone. Secondly, of course, it should be fast and robust. And third, it should give you all the information you need for your site assessment study in a well-presentable format. But how does the real world look today? Often CFD tools are only usable by trained users, as terrain and measurement data need to be converted and a good mesh needs to be created. CFD solvers often face convergence issues, which make it hard to get fast results, and often the results are only presented in tables, graphs, and cryptic formats. So what have we done about this? During the last year, WindSim AS has developed a graphical user interface, which is intuitive to use and shortens the time to set up projects in CFD tremendously. Setting up a CFD model now takes only some minutes instead of hours, and this is the WindSim Express. What contains the WindSim Express? First of all, geographical data can be downloaded directly into WindSim by just specifying your park layout. Wind measurements can be imported into WindSim without any need for data conversion on the customer side. Then you can specify your park layout easily from Excel. And then, according to your computer power and the layout which you have given to us, we suggest you the resolution of the calculation. Then the meshing is done fully automatically to ensure that your park is resolved in the best possible way. We also improved the post-processing a lot. You get an automatic cross-check between measurements to understand the accuracy of your model. You get an export to the so-called WAT format, where you can easily do site suitability studies with, and you get a Word and PDF report with your results. All these features you can find in WindSim Express and in the WindSim 6.0. The WindSim Express will be available with the upcoming WindSim 6.0 license. It's thought to be a quick and easy start with WindSim. You can, in any step, switch back to the full version. The easiest way is to switch back after loading the layout, the terrain and roughness data, and the measurements. Now I will give you a short demo about WindSim Express and how it will work. This is the introduction page from WindSim Express, so you see, when you're familiar with WindSim today, that it's a much easier look and feel. We have created a 3-step procedure. So the first is that you will set up your project. Then you will give us the position of your objects, so like the turbines and the measurements. Then we will download the data for you from the internet, and then we will put up the simulations. So we will do the gridding and the extension of the area. In the end, you will get back a PDF and Word report. In the first step, we have to define the project name, then a layout, and also the customer. And then we come already to the import of the layout. So when we click on the layout button, you get asked about the turbine. So there are some predefined turbines in our database where you can give the turbine height and also the rotor diameter. You can also create an own power curve if this is needed. Then you can insert the turbines. For example, if you have already an Excel sheet where the turbine positions are specified, then you can just easy by copy and paste insert the data into your WindSim Express. What you also can specify is the coordinate system. So here we are quite flexible. You can give whatever coordinate system you have, and we will convert it to UTM, which is the used format by WindSim. Setting up, we get the so-called OWS file, which is for WindSim users, the well-known format where we specify the turbine and positions. Then you can import a time series. Here we have improved a lot. You can, for example, load a CSV file, so you can load several measurements at the same time. We then try to specify the single columns which are in this file. For example, here we have automatically detected wind direction and wind speed. And you could also, for example, specify new columns. For example, here is also the standard deviation inside the file for the two heights. And then you would specify for which height the data is valid, if this has not been clarified automatically. And then you can verify by looking at the columns below if you have specified in the right way. When you then press to convert, you get asked about the position of the climatology. Sometimes we can detect this already from the data file, like here. So then it's easy copy and paste to set this inside. And then again, you get asked about the coordinate system. So in fact, you could have the measurements and the turbine positions in different coordinate systems. The next step is that we have to define how many simulations we want to run. So in this case, normally the default is that we run 12 different wind directions. For the demo case, I will run only 4 wind directions to be a bit trigger. Then we convert the data, and you can see that here already the measurement is in the well-known WindSim TWS format. The next step is to decide which terrain and roughness data we want to use. So here you can see the online data source. We have here the choice between ASTA and SRTM dataset. So the ASTA is usually a resolution of 30 meters, which we will use in this case because it's the best possible resolution. And then we have also different roughness datasets. Here the best to choose is the Korean land cover, which has a resolution of 100 meters. And then you have different possibilities to place a map behind to get a better visualization of your park. After you have set the online data sources, you can go to the next step. And now we will automatically download from the internet the data for the park. This usually takes some minutes depending on the internet connection you have. Here you can already see we have fully downloaded the dataset. When we zoom inside, we can already recognize the turbines and also the measurement here on the left-hand side, where we had 2 measurements in 60 and 80 meter height. What you can see here is the terrain map. You can also switch to the roughness to verify that the roughness map looks okay. And you can also put a picture behind to see that the turbines are really placed the right position and the right way. When you are convinced that everything is set up the right way, you can go to the next step. And in this step, you can decide about the resolution. What you can see here on the left-hand side is the total number of cells you are able to run on your machine. And this depends on the RAM. So for example, here I can run around 3 million cells because I have an available RAM of around 4 gigabytes. If I slide, the black line shows me always where I am. So if I would run with a resolution of around 30 meters, then I would really push my PC to the limit. Of course, for the demo we will not do this, so I will go to the lower limit and put around 10,000 cells and end up with a resolution around 100 meters. When I'm confident that this is the setup I want to run, I just click on the next button and automatically all modules in WindSim will be run. So the first thing what is set up is the terrain. So we process now the terrain and the roughness data, and here you can already see some information about the terrain. So we get specified that the extension of the area is around 10 kilometers in each direction, and that the total number of cells, which I'm running at the moment, is 10,000 cells. The same is then done for the objects module. So we actually place the objects inside the module, and here we already get the information that we have 19 objects, 17 turbines, and 2 climatologies. What you then can see next is the pop-up of the wind field. This might also be familiar to many of you. We have made this in a much easier way, so you get the progress bar here, which shows you the overall progress of your project, counting all the sectors. So at the moment we have run the first sector, and the next 3 sectors will follow shortly. Of course, this is running quite quickly in a real-world application with 1 or 2 million cells. This would, of course, take some hours per sector, depending on the capacity of your machine. On the left-hand side, you can also follow a bit the timeline. So here you can see, if you have a real-world simulation, you could see how many time has gone since the last simulations. So you can always keep the overview of the status of your project. For this demo project, we already reached now the last sector. So we run the 4th sector now, and it will shortly complete and go over to the result calculation. When running the results module, this is really only for the visualization of the wind field simulations. We plot variables like the 2-dimensional wind speed and the inflow angle to get you an idea about the quality of your simulation. Here you can see already that we have plotted the inflow angle, the speed 2D, turbulence intensity, and the speed 3D vector. After this, it goes on in the wind resource, where we really calculate the mean annual wind speed, which is then based really on the measurements. So this is then really the realistic mean annual wind speed you can expect at your wind farm. And then in the end, we do the annual energy production, which is then given the total over the complete wind farm. When the project is ready, you can also switch back to the WindSim, so to the full version, and inspect further the results and change settings if you want to. So as you can see here now, everyone who is a bit familiar with WindSim can see that all the modules are green. So we have run successfully the complete project. First, of course, here the setup of the terrain. Then you can investigate the wind fields. Here you see the convergence plots, that all the simulations are converged. Then you can inspect once more the turbine positions and then you can go into the details and check the simulation results of your project, and then also look at the wind resource map, which is then really the weighted results of the CFD simulation. And then in the end you can have a look onto the energy, looking at the energy, the annual energy production. Going back to the presentation, I just want to highlight shortly once more where the terrain and roughness data comes from. This is the Global Mapper API, which we have included in WindSim. So all the data sets which are available in Global Mapper are principally also available in WindSim, and then we automatically convert this to our formats. The best possible resolution which you get is 30 meter. Shortly a bit about the data sets which are implemented today. So the available data sets online is the ASTA data set and the SRTM. And then for the roughness we have the Corinne data set, the NLCD in the US, and then the VCD in the whole world. In case you have to work offline, which can happen sometimes, then we can provide you the SRTM dataset in a 90 meter resolution for the terrain, and we can give you the globe cover dataset for the roughness in a 300 meter resolution. Now a short overview over WindSim 6.0, which is really the engine behind the WindSim Express. This means that all new features in WindSim Express will also be in the WindSim 6.0. And the new features will include an automatic gridding. This means that we will have an automatic refinement area around the park. So when you have a look onto the left-hand side, you can see in orange, this should be 2 turbines. So we should automatically do a refinement in around the turbine area and then extend to the borders. On the right-hand side, you can see the vertical gridding. So we will do a regular horizontal cell distribution up to 200 meters, and then an expansion factor above. So we will ensure that you get a good resolution over your turbine height. The next improvement we did is the convergence criteria. If you are a bit familiar with the CFD, then you know that you normally specify how many numbers of iterations you want to run in a WindSim simulation. Normally these iterations are always run up to the maximum, but we made it possible now that we detect if a simulation has converged, and then we'll automatically stop this sector and go to the next one, so that you can save a lot of computational time just by not that it's not necessary anymore to run unnecessary iterations. The next improvement, what we have done for WindSim 6.0, is the so-called GCV. It's General Collocated Velocity method. This means it's the way how the gridding is done. When you have a look onto the right-hand side, then this is how variables are placed today in the numerical grid. This means that the scalar variables are not on the same point as the vector variables, and this leads to instabilities. In the new grading method on the left-hand side, everything is within 1 point and makes the simulation much more robust. So far we haven't found a single case with divergence when the grid is set up in a reasonable way. The validation is still ongoing. A nice post-processing feature which we have created is the cross-checking. In case you have given time series to the program, they are automatically transferred to the other MetMask locations, and we give out an ASCII table about the results in the wind resource module. So you can easily see how good one MetMask can be transferred to another MetMask and get an idea about the accuracy of your model. Another feature in WindSim 6.0 is, of course, the park optimizer. Here I want to remind you about our last webinar, which you can also find on YouTube if you want to get more information about the park optimizer. Another post-processing feature is a WAT export. This is new under the energy module, and in case you have given us time series, they are automatically transferred to the turbine locations and write out variable parameters per turbine per sector, speed-ups per turbine per sector, and weighted ambient turbulence per turbine per sector and per bin. This will then all be summarized in ASCII tables, and this you can use to do easy site suitability studies. And one of the last new features is the reporting in Word and PDF format. So as you can see here on the left-hand side, we will have a content list which contains more or less all the information which you see today in our HTML report. This will then be placed directly into a Word format where all the pictures and tables are contained, which you see in WindSim today. This Word format can then be edited by the user himself to determine which parts of the project to use for his own report. About the new developments we will have in the next months, we will release a cloud version soon, which will make it easy for you to do big calculations in a really short time. Here we will have the next webinar in the end of the first quarter 2013. Then we plan to release a load module, which will give you an easy overview over the loads on the single turbines, and we will implement mesoscale data in the WindSim Express. We hereby invite you to try it out. So we will release the WindSim 6.0 end of the first quarter 2013. And if you would like to try the WindSim Express already now, you should write an email to me, to katrinmeissner@windsim.com. The important thing for this is, of course, that you have a running annual maintenance agreement. Further on, I would like to invite you to take contact with us whenever you have questions or you want to try the WindSim Express. Feel free to contact us under the given telephone numbers or the given email address here in the list. Thank you for your attention. We will now go through the chat things, and then I will answer the questions which I have obtained via the chat. The first question which came in was if WindSim is able to capture and to visualize recirculation. Yes, of course, WindSim is able to capture recirculation. This is what the CFD model is for, and you can also easily visualize this. We have in the objects module a 3D graphical tool where you can easily visualize, for example, the wind direction and the wind speed, so there you can easily see the recirculations. Then the next question is if there's any recommended standardized minimum resolution for the analysis. Of course, there is no standard, but we normally recommend to have a good CFD study should be run on at least 25 meter resolution to ensure that you capture all the important effects. If you are in a really, really complex terrain and you know that you could have recirculation, then it's even sometimes worthwhile to have a even better resolution, as long as your terrain data has also a good resolution to capture the effects. The next question is, what turbulence model does WindSim use? WindSim has several turbulence models. So the standard is the K-epsilon model, but we have also in the last years implemented the K-omega model from Wilcox. Then we have another question. Can we include long-term data, more than 10 years, from near Met towers? And can we develop MCP analysis? You can include long-term data, of course. This is also required in WindSim, that you should include long-term data. Of course, these met towers should be within the simulation area, so they should be in the range of around 30 kilometers around your turbines, and they should, of course, be also a bit representative for the area where the turbines are placed. Then the question is, can we develop an MCP analysis in WindSim? You can't, but we have a cooperation together with Windographer, and they have in their recent version developed an MCP analysis which you can use. And Windographer can directly export to our TWS format. So this means if you make the MCP in the Windographer, you can directly use the time series in WindSim. Then there's a question what happened with terrain databases on South America, Chile and Argentina. This is covered, so the terrain is covered by the SRTM and by the ASTA dataset because they are global datasets. Of course, for the Chile and Argentina, you can't use the Corinne land cover, but you could use, for example, the globe cover dataset, which has a 300-meter resolution and is a quite good dataset. Then we have another question about the map files. What is the recommended resolution? 1 meter, 5 meter, or 10 meter? For us, of course, the better the resolution, the better it is, but then it depends also how we convert it. So normally we have a limit in the conversion, so normally if you come with 5 to 10 meter resolution in the map files, this is sufficient for WindSim. Then we have a question about the bad wind measurement data. Of course, bad wind measurement data, we cannot do anything about in WindSim. Here I would also refer you to the Windographer, because Windographer is a really nice tool to clean the wind measurement data before you give it to WindSim, because in WindSim we would really assume that you only have cleaned data inside the simulation. Then there's another question. Are there all the coordinate systems available? Almost. So when you are a bit familiar with the global mapper, then you know that they have a really long list of coordinate systems. And if some of the systems are not available, it's possible to program them inside. So I would invite you to try the WindSim Express and see if your coordinate system is available, or you also send me an email where you state which coordinate system you want to use, and then we can check if it's available in WindSim. Then we have a question, if I could please show again in the post-processing of WindSim Express if it is more powerful as WindSim Basic. No, it is not more powerful than the WindSim Basic. In fact, when we run the WindSim Express, at the moment we run the standard settings from the WindSim Basic. So if you want to have a more advanced setting in the post-processing, then you are invited to switch back to the full version. So to set up your project in the WindSim Express, and then run the wind resource and the energy module in the full version, where you have much more freedom to change settings. Then we have, do you have an academic pricing for WindSim? I think here Olaf can send the price list. Of course, we have a 70% discount normally for the pricing. So if you're interested, you can send an email to info@windsim.com and we will send you a price list. Then we have one more question. Except auto refinement, can nesting be also used in WindSim Express? So far not, because the WindSim Express should work without refinement, without nesting. So we assume that by using this auto refinement method, we should be able to capture all important effects around your park. Then there's a question if you can send the presentation via email. Of course, I mean, we can do this. Here's the same. Please send the request to info@windsim.com that you want to obtain the presentation, and then we can send the presentation via email. Then there is a question how to obtain terrain data, for example, for Singapore. Here's the same. You would basically do the same. You would go into WindSim Express, and then you would specify where your turbine should be placed in your coordinate system. And then we will download the data automatically for Singapore. As these are worldwide data sets, you will also get the data for Singapore. Then is a question if you need many iterations to get the converged solution when using the new method of the general collocated velocity. Here we can say no, so you need even less, if you are familiar with WindSim, then it's even less iterations than you need for the segregated solver to get convergence. So normally the single iterations, it's a bit like the coupled solver, that the single iterations takes a bit longer. But for this you get a faster convergence than before. Then there is a question about how do we calculate the long-term wind conditions, if we would do this with MCP. Yes, of course, so this you would normally do with an MCP, but this you have to do outside of WindSim. Then we have a question about, usually we get 1 meter resolution inside the target terrain and have to use SRTM for surroundings. How does this affect WindSim results? This depends a bit on how large your target terrain extends over the pure turbine area. So let's say if your really high resolution is around extends 2 to 3 kilometers in each direction away from the turbines, they should not affect the WindSim results too much. Of course, the SRTM has only a resolution of 90 meters, so this is not thought to deliver completely nice results in the turbine surroundings. But as long as your data set extends enough in all directions, you should not have any problems to use the SRTM in the surroundings. What you of course have to be careful about is that you always normally have merging effects. So you have to see if you have some sudden jumps in the terrain height or in the elevation. Then we have the question about if we have some validation publications. Yes, we have. You are invited to go to our webpage, www.windsim.com, and there you will find, it's on the publications, I think, even. There you find a lot of validations, and if you have questions about special topics, for example, if you want to see a validation about the use of forest or things like this, which you maybe can't find on our webpage, you are invited also to send us an email and to ask about, because we have not published all our validations, so we are also for sure able to send you some more detailed publications to specific topics. Then there's a question if there are online data available for Iran too. Yes, there are. I know that people here in the office have used WindSim Express successfully for Iran, so it should be possible for you to download data directly from the WindSim Express. Yeah. So these were all the questions so far. Is there anyone more who wants to put a question to us? If not, maybe I can give back to Donna for a conclusion in the end.
Okay, so we would like to thank you all for joining us today. and we look forward to working further with all of you, and we will conclude our session as such.